Okay, so we are in our last lesson on the periodic table unit. If you'll keep watching for the test review video, that should be up within a few days as well. Your test will be on Tuesday, Wednesday, Thursday of next week, depending on what block you are. Check Moodle calendar to see your specific day. And let's get started. So we already know one periodic trend, and that's atomic size. Today we're going to learn two more trends, the ionic size trend and the electronegativity trend, or ionization trend. We're going to also compare the size of cations to anions. Okay, as you recall, cations are positive charged ions. That's all they are, just a positively charged ion. And sometimes you'll lose an energy level to have a cation. So for example, let's see. So for example, if sodium were to become a cation, so it has 11 protons. So sodium, we'll just say here's the nucleus, okay? It has 11 protons and it has 11 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 11. So the neutral atom of sodium has 11 electrons. Now, if we were to take one of these electrons away, so if we were to take one of those electrons away, we will have a loss of energy level. So this energy level will not be a thing anymore. It goes away, and then we will have this type of structure. If we're looking at the Bohr-Rutherford, that's the nucleus, not an electron in the middle. And notice that it is isoelectronic. We learned this word earlier, electronic. We learned this word in an earlier lesson. So it's isoelectronic with, so it has, this one has 11 electrons, this one has 10 electrons. So this one is isoelectronic with neon. Okay, it has 10 electrons just like neon. Now keep in mind, it's sodium still has 11 protons but only 10 electrons, so it's isoelectronic with neon. And that's what, just to kind of bring you that word back. And there will be more protons than electrons, so there are still 11 protons always, okay? Remember, we never change the number of protons, so there's still 11 protons but only 10 electrons. Obviously, that would have to be true in order for the ion to be positive. Okay, so the more electrons cations lose, the smaller the ion becomes. Okay, so for example, magnesium, okay, which is right here. If magnesium loses one electron, it becomes smaller. Okay, and that's because now we have one less negative charge to balance out the 12 protons. So now we have 12 protons, because that never changes, but we only have 11 electrons, so the cation is going to be smaller, magnesium. And then if we lose even another electron, that's going to be even smaller. So for this example, this is actually smaller for a couple of reasons. For one, we've lost an energy level, and for two, now the positive charge outweighs the negative, so they're going to be pulled in a lot more. Okay, so anions are always larger than the neutral atom from which they are made. So that's just due to there are more negative charges now, more negative particles that are being acted upon by the same number of protons. So for example, an anion is, we drew fluorine, but we'll draw chlorine, 17. So chlorine has 17 protons. We won't worry about the neutrons. And we'll just do this so we know it's not an energy level, it's a nucleus. Okay, so chlorine has 17 protons. And neutrally it has 17 electrons, which will be 3 energy levels. Sorry, there's a big tractor right outside. Okay, so that should be 10, 11, 12, 13, 14, 15, 16, 17. Okay, so this is chlorine. So this is neutral chlorine. I should probably say that, neutral. So that's neutral chlorine. Now, if chlorine were to become -1, okay, so chlorine with a -1 charge, then it's going to gain this electron. So this would be now chlorine with a -1 charge. It has this extra electron. So now there are 18 electrons and still only 17 protons. So the attractive forces are now distributed amongst 18 electrons. The positive force is distributed amongst 18 electrons instead of just 17. So it's going to be slightly bigger. So the trend for anions is that the more electrons that are gained, the bigger the ion becomes. So chlorine with a -1 charge is going to be bigger than neutral chlorine. And chlorine doesn't really go past a -1 charge, but for fun, well, okay, I don't even want to use chlorine because it just doesn't do that. But oxygen I do use as an example. The neutral atom is going to be smaller than the atom with the 1 electron gained. Okay, so that's 1 electron gained, and it's going to be bigger than this one. And then if oxygen, which does get a -2 charge, got a -2 charge, it gained 2 electrons, and so therefore it's even bigger than this one and definitely bigger than the neutral one. Okay, so electronegativity, all that is just how much an element can pull in electrons when it's bonded with something else. So, like for example, fluorine is the highest element is the element with the highest electronegativity. So, if it's bonded with, for example, hydrogen, it's going to pull in the electrons closer to itself from hydrogen. So yeah, and you'll notice that I don't know if I don't have a picture of it, I'll explain it better in a minute. But so it has a trend. The group trend for electronegativity so the group trend is as you go down a group, electronegativity decreases. And as you go across a period, electronegativity will increase. Okay, so and the good thing is that the reason this increases and this decreases is literally the same reason that atomic size increases and decreases. So this will increase because of increased number of protons, or that positive charge in the nucleus, which is able to pull in the electrons towards itself from the other atom. And then the electronegativity decreases, again, for the same reason I taught you with atomic structure, because of the increased number of energy levels, or as some of you insist, occupied energy levels, which is good that you insist. So, there's a slide that kind of shows you the electronegativity trends. You'll see that fluorine is really high, and then it kind of goes down as you go down a group. It gets smaller, and as you go across the period, it gets higher. So just keep in mind that this is actually opposite of the atomic size. Okay, so just keep that in mind. But the reason they are changing is because of the same reasons. Okay. And then this, I just kind of gave you just an overall view of the periodic table. You have the atomic radius, and all of this is increasing. Everywhere the arrow is pointing is increasing. So atomic radius increases as you go down, increases as you go to the left. Ionization energy and electronegativity increase as you go to the right, and increase as you go up. Okay? And then metallic character. Remember, this is kind of gradual change. That's why you have this metalloids section over here, and then you have some scientists debating on which one is a metalloid, when honestly this is just a gradual change. There is no, okay, we have stepped from metals to non-metals. It's just gradual. Okay, so that's it.